going to start on a we're going to start on a genetics theme, and then move to some parasitology, and finish up with Jeff talking about two very different things. So first of all, I'd like to invite up Suzanne Rowe, who's a ag research scientist, to talk to you about some genomics work.
Yeah, about 6 minutes.
Thank you, Suzanne.
Okay, so my name's Suzanne Rowe. I work in animal genomics at Invame. I develop genomic tools, but that's not actually why I'm here today. I'm here because Catherine asked me, or asked Genomes, to give an update on their adoption of a new technology for parentage. And as I was involved in helping to develop and adopt that tool, then Genomes kicked me out in front and said, go tell them what we're doing because we're way too busy doing it. So that's why I'm here. Over to me. Am I? On the left. Okay. So I drew quite a few parallels when we work in animal breeding. We work in genomic technology, obviously, with Kyla's talk yesterday. In 2000, they sequenced the human genome. It cost $300 million US. Now we can do it for about $1,000. So yeah, we draw these parallels every day in the technology that we use. We had the opposite situation up until this year, whereas Genomes were limping along with a microsatellite test that they designed in 1997. And with the advent of tools, you can imagine that tool was pretty tired. So I'm just going to start by, because I couldn't resist this, talking about why we need parentage in the first place, because I'm a scientist and they've given me a microphone. And everything they say about scientists is true. So this is just to demonstrate that when we have genetic progress, and I just picked carcass weight, I could have picked any trait. It's got a moderate heritability, and this is progress per year. So this is genetic gain in the herd per year. So the average number of grams you can put on if you get your breeding absolutely spot on. And this is accuracy. And the reason I put this up is because most people don't understand accuracy. So when I say we've got a breeding value with an accuracy of 0.4, most people think that 40% of the time you're going to get it right, and the other 60% is rubbish, and you just need to go away and feed your animals better. What an accuracy of 0.4 actually means is you managed to pick 40% of the top animals you were aiming for. So you're going to make roughly 40% of the maximum gain you could have made if you knew everything about every animal. So we're still making gain, but we're making it slower. And obviously making 100% of the gain that you could make if you could see inside the animal and knew its genetics is rarely going to happen. So actually an accuracy of 0.4 to 0.5, we're pretty happy with that. That's pretty cool for most technologies. This is contentious, but I'm telling you, you cannot see your genetics, okay? Most heritabilities are around about 0.3. You cannot look at an animal in a paddock and use that as a breeding tool. You'll make roughly 10% of the gain that you could make. So guys, stop it. So when we know a parent and we get a breeding value, suddenly that accuracy jumps, and it's linear. Not everything is exponential. Some things are really linear, and this one is. And we make more gain. And if we have two parents, we make a bit more gain. And when we start to measure progeny, then we really start to accurately get a handle on which are the best animals to choose for parents. And that's all we need to do, is choose the parents for the next generation. And then when we add in genomics, we start to get really, really accurate. We start to get really good at it. Then obviously we get into this issue of, if we use genomics, there's a cost to it. We have to measure many, many, many animals to get these sort of accuracy. So it's not a magic bullet. It still needs money. It still needs time. And it still needs phenotypes. But this is why, as animal breeders and geneticists, we're always pushing towards more information, genomic information, because we've seen what the effect is of pushing practical genetic gain in the herd. So that aside, this is why we want parentage. I'm going to go on with the show. And talk to you about what's happening in genomes, what the process is, why some of your results are late, and I know they are, and where they've got to in adopting the technology. So genomic parentage. This is what happens on farm. My apologies. I know that's a sheep, because I'm a scientist. So you guys are taking a sample, and it goes into one of these little things, and hopefully you fill in this form, you chuck it on the courier, and then you phone Genomes and say, where are my results? The sample comes into Genomes, and the first thing, we get about 150,000 of these through the lab every year. So if that sample doesn't have the paperwork with it, we can't do anything with it. The worst thing that we can have, and we get it all the time, is a brown envelope of samples with no information. That is our worst nightmare. So that pitches up with this piece of information, is accessed into the database, and we try and get that done within 2 days for whatever comes in the door. After that, this is where the magic happens. The cap gets taken off, the DNA gets extracted, it gets quantified, we look at the quality, we make sure it's good enough, we chop it up into little bits with an enzyme, we extract 2%, we stick a barcode on your DNA, and it tracks back to your individual animal number, and then it goes into wells like this, and it goes through a robot. And that takes about 12 days, mostly because there's a lot of QCing involved. So once it's ready, it goes onto one of these things that, was worth billions not so long ago, and now we've got one in our lab. This is the equivalent of the driverless car for us, I think. So that adds on about another 3 days. When all the information from these little fragments of DNA comes out the other end, the computer sticks it all back together again for us with the help of a friendly bioinformatician. So that adds on another sort of 4 days. And finally, someone at the other end gets the information and sticks it all back together, and you guys get parentage. So the minimum that this can take is 3 weeks. And at the moment, I know that Genomes is quoting about a 5-week turnaround. And this year, with the new system and the upgrade and the training, it's probably somewhere more like 8 weeks at the moment for the average turnaround. But it will get down to something that's sensible, because this is happening for many thousands of samples. What's it offering right now? Why would anybody bother to do parentage in the first place? Well, now that they've switched to the new technology, they're actually using about 75,000 markers as opposed to the 15 that they were limping along with. So there's a huge more amount of information, which means we actually get the relatedness of every animal in your herd with every other animal that we have. So there's much fewer mismatches. You can imagine 75,000 pieces of information means that we can accurately separate animals and verify pedigrees that previously we couldn't. Much easier for on-farm recording. We don't need mob now. It's much more powerful. Before we would need the mob, and we would need which stags went to which hinds, and we would sort of try and tease apart with these markers, whose baby. Now we can just throw it all into one big mix, and the computer sorts it out for us. And we can also get much more accurate breed composition. And the disclaimer I would put in for this accurate breed composition is that we have a prediction equation, but it's based on the standards that we already have. So that breed is only as accurate as the standards that we use for a reference. So if anybody looks at their breed composition and says, I don't like this, then you have a couple of options. You can come back to us and we can relook at it, or we can think about getting a standard that really reflects what's on your property. And I would really encourage you guys to feed back. If you see anything in your new results that you don't like, give me a call. Don't sit on it. We want to get this right. So challenges for Genomes. Obviously, if we switch to a new technology, we had to regenotype parents. People don't like redoing things. They don't like spending for redoing things. We got around this by asking AgriSearch to subsidize. So we made it as cheap as we could. It's been really tough getting animal information on everything that's been coming in. Multiplexing is obviously difficult. We've scaled up. Guys are dealing with often 100,000 versus 16 markers. A new method of analysis. So there's been a lot of upskilling. There's been a lot of training in the lab on the commercial side. But the biggest issue is late or missing samples. If we get a bunch of samples in and it's missing a sire, and the sire comes in a week later, it's already in that 5-week production run. So then they have to wait to get onto the next production run, the next queue on the sequencer, and then it takes all that time to come through again before we can do the parentage. So I really would urge you guys to get your parents in before your progeny. It speeds things up immensely. And finally, why am I interested in it? It's not just for parentage. We get levels of inbreeding, we get precise genomic relationships. And I really like the idea of looking at these markers linked to genetic differences with large effects. So what I'm doing is I can take all this information now that's coming in, you guys get parentage back, I get heaps of data. And if you guys are happy with it, all I need to do then is take your phenotypes, link them together, and start looking for predictions for genomic selection, but also for those big hitters. You know, for those genes of large effects that are probably sitting around. You have really high heritabilities in your traits. That means there have to be a few big genes in there circulating around that we can go after and make our predictions more accurate. And I have to believe that there's some genomic traceability or some scope for genomic traceability in what you guys do, given that looking at the marketing talks yesterday. So actually, I'm not going to talk about tomorrow's deer because Jamie is, and I'm probably out of time. But one thing I will say from yesterday is one of the things that I got from yesterday's marketing talks was non-GMO, non-GMO, non-GMO. Now, I'm not particularly pro-GMO or against GMO. It's not an area I've ever worked in. But at the moment, as breeders, there are new tools out and it's called gene editing, where if a breed has some sort of trait that's developed, it's usually something like disease resistance, and it's really useful. We can take that from one breed and put it into another, and lots of people around the world are using this technology. It's being used for welfare, so the Chinese know the gene for short tail. They can just pop it into their populations. They don't need to tail. Now, I'm not advocating that, but what I'm saying is when you advertise your product as non-GMO, be aware that a lot of the new technologies coming through involve moving genes from one breed to another. So just be aware that it's a tool that maybe you want to use in the future. Maybe you'll have to make a decision in the future. So don't shoot yourselves in the foot. And that's about all I need to say.
Thank you very much, Suzanne. As a former scientist, that's a debate I'd love to get into, but not today. So, over morning tea, indeed. Thank you, Suzanne. As St. Bruce of Cotterell said yesterday, repetition and consistency of message are very important, so I'd like to invite Sharon McIntyre, our Deer Select manager, to the stage to remind you about what's cool about Deer Select. Thank you, Sharon.
What's cool about Deer Select? Everything. So I press this and something happens. Cool. Sharon's turn. Okay, so my career has all been about genetic improvement. I don't work in the genomic space like Suzanne, but you only get, when you make your decisions about buying a stag, whatever stag you've got out now at the moment or you've got in already, those hinds will be in your herd for the next 10 years. If you made a good choice, that's some improvement. If it wasn't a good choice, then you're status quo for 10 years on those hinds. So something you need to have a strong think about. You only do it once a year. The deer industry's been quite amazing, both in the red deer on the top graph here. This is a spread of BVs that are available for growth. So the weight 12 is along the bottom. The red line is the 1995 average. You can see huge improvement in growth. Animals of merit right across the scale are available in both terminals and in reds. Growth is where most of you will get the biggest bang for your buck in a venison situation. We now have animals at over plus 34, I think it is, in red deer, and we're at about plus 20. We've done some manipulation in the wapitis because of some back data issues. But what I want to emphasise to you is that BVs are real. They result in real differences that you will experience on your farm. So this is 11 sires, and they had progeny. I've got 10 or 15 male progeny per sire. And the black line along the bottom, he's a very good sire, but he's a second cycle sire. So we can see the effect of birth date. He tries to catch up, and he's a lot closer by weight 12, but he never actually, his progeny never make up for that being born later. So things like the body condition scores and the feeding the hinds and your kill date, it all comes in together. So those various lines, they are animals that vary from a plus 10 for weight 12 to a plus 26. At the bottom end, there's 10 kilos difference in weaning weight. If we ignore the bottom one, the late borns, there's 10. The difference of 16 kilos in breeding values resulted in 10 kilos difference at weaning weight. 10 kilos, $5.50, $55 a head if I'm selling those weaners. A plus 10 is still well above a lot of the sires that are used in the deer industry. At the top end, you can see that we've got about a 16 kilo difference in carcass weight at the chill time, 16 kilos, $9 a head. Well, 16 kilos, you've got to halve it for the carcass weight. So about 8 kilos of carcass weight at $9 a kilo. Quite big sums that can be returned to you just by making a good choice of which sire you put out. So we've done the growth really well. I think there's choices for everyone available there. But what about conception date? We saw that those late-born fawns never quite caught up. So one of the things we've got now is we've got the early conception. This is where our breeders put stags out early with generally with young hinds, and they do a pregnancy scan where they get the fetal age. We can tell when they were conceived, and we have stags out there that are minus 9 days early, so 9 days shorter in conceiving than others. Deer are very clever with day length and things, and they tend to modify things a bit, but a 7 days earlier will generally result in about a 5 day earlier born fawn. We're in the process of developing some breeding values around reproduction. I think it's really important that we've had this great progress in growth, but we don't want to lose that great fertility that our red deer and all our deer have. So we want to make sure that we don't have any negative impacts. We're only ever going to have probably one, in most cases, one fawn per hind. It's not about number of lambs born like it is in the sheep industry. But we don't want to have any negative impacts from our selection processes on reproduction. So that's a process that's underway with some scientists at the moment. Meat, this is an area that we've had huge advantages in recent years with the deer progeny test, and I can't speak highly enough of the Alliance staff that I was involved with when I was in the plant helping with the test. We were a real pain, I can tell you, but they were very accommodating. So we learnt from the DPT that larger loin areas are associated with increased tenderness, increased meat eating quality, and experiences of the taste panels. We also know that it's associated with heavier muscling in the primal cuts. Seems like a win all round. That's not the case in all animals. In some animal livestock species, high yields are associated with poorer eating quality, which is not somewhere we want to go. We want to be a premium experience. So we're in this wonderful position where improved loin and muscling gives improved eating experience. The bottom of the graph, this is a range of the current sires that have progeny out there in the last 3 years. So we have animals that are +3 square centimetres, which I'm guessing is about this much. So if you add that, maybe a wee bit smaller. Yeah, if you can add that amount of meat onto a carcass, the sheep industry have been amazing. Their ewe numbers cut in half, and they maintained their lamb carcass weights, the total amount of lamb that was exported. We're in this position where hinds are being retained, our kill rate's going down. If we can take a similar approach using growth and some meat, if we can keep that volumes of venison available to the industry up by putting more meat on the animals we currently have, we can reduce that supply gap for our processing partners. So that we have herds out there, both, this is red herds, but in our Wapiti and in our red herds, we have about six reds and 4 Wapiti herds that now have meat measurements going back 6 or 8 years. So it's not unproven. The accuracies we are achieving are very good in meat, and in conception date we use the 50% accuracy that Suzanne was talking about. We're in the process of rewriting the whole meat module based on the really good science that came out of the deer progeny test. We've got lots more information, and we'll have a much better analysis available to the industry. But those herds that have been selecting on meat, you can see that's the genetic trend for eye muscle area, and you can see since about 2007 we've actually going up in eye muscle area, so it is actually coming through in the stags that these guys are providing to industry. This is just a little bit different. As part of the P2P process, we have try and think of ways that we can help the P2P people and farmers in general. And And one thing that came out of it was the use of terminal size. Terminal size can be high growth reds, they can be hybrids, they can be wapiti, they can be elk, they can be anything that you want to call a terminal sire that has high growth rates. So this is a wee tool where you can put in your hind numbers. You've got various adjustments that you can make about, do you keep first calver fawns, yes, no? Do you keep your dry first calvers, second calvers? What's your fawning percentages, weaning percentages? And it works out from that what you can do with your animals in terms of how you can mate them to the appropriate size. So it also gives you a wee age distribution. At the moment, this program is an Excel-based program, and I've got all the calculations behind it. And the Abacus people who are going to make this beautiful app for us, for the millennials who like to do it all on their phone, it's going to cost quite a lot. So one of the things I want to be sure of is, one, are my calculations correct? And two, is this going to be something desired by industry rather than, you know, just something not? So I have an Excel spreadsheet. If anyone wants to play with it, check how it works with their numbers, I'll be most interested in talking to you at morning tea. So thank you for your attention.
Thank you, Sharon. Slight change of topic, but we will cover genetics a little bit. Jamie, who is that man? Does anyone recognise this face?
Thanks, Catherine. So this is something a little bit different. This is the fecal matter session of the day. So you see there over on the left, our comms people at Ag Research now want us to connect with the millennials, and so they want us to use emojis. And so the old digit plus the proverbial, the back end of the deer equals what? And for me, that definitely equals parasitology. So this is a summary of the 3 lots of parasitology work we've got going on at the moment. And the important thing with the parasitology work we've got going on at the moment is that it's about addressing some of the challenges that we faced when we realised that, hey, actually moxidectin porons weren't really doing the job for us. But it's also about some of that stuff you heard about yesterday. It's about having the best animal welfare outcomes. It's about having the lower input systems and all that sort of thing. So within this, we've got tomorrow's deer, we've got the multi-day bolus, and we also have a drench resistance assay that we're trying to pull together. So in tomorrow's deer, it's our new flagship genetics program, and what we're looking for there is to find genomic and genetic measures of traits that are going to be important and valuable to the industry, but that are difficult and expensive to measure. And to kick off with, we're looking at the well deer concept. So we're looking for immune competent deer. And one of the things with that in terms of the parasite side of things is that we want to reduce chemical interventions or drenching over the long term. So how are we going to achieve that? This year we've got 2 different things happening. We've got the CALA trial, which is all about this CALA immune IgA response to parasites, and we've also got the biomarkers trial, which is in conjunction and collaboration with the DRL team, so Frank Griffin, Rory and Simon, in terms of Johne's disease and the biomarkers that they have for disease. And all of these get run through the GBS and at a much higher density, so a whole lot more markers than we use for the pedigree testing. So the CALA trial, just quickly, is about determining the productivity impact that we can have using this CALA marker. So in the DPT, we found that there is a genetic response for the CALA. It's a heritable trait. So now we're looking at, well, okay, it's heritable, but does that heritability actually mean anything production-wise? Have we got animals that can cope better with the parasite challenge and grow better, or have we just got animals that are got a hyperactive immune system like me? And the design for that was around 2 sires identified in the DPT, 2 high CALA sires and 2 low CALA sires, 2 reds, 2 wops, 1 of each. And these animals are being naturally parasitized. And so that is meaning we're grazing them at lower residuals to try and just pick up the natural parasite challenge that we've discovered runs around Invermay pretty well. And half of those animals are drenched what we call suppressively, so every 2 weeks we're hitting them with a triple combination, and the other half are only drenched when we have to, and we have certain triggers around that, and to date the main trigger's actually been the relative lack of gain or loss of live weight. And so the key productivity metrics for this are the live weight or the lack of live weight gain and that Kala response. Now below that you can see a couple of graphs, and so this is the work with the DRL team that Frank Griffin and them had funded through Sustainable Farming Fund. That's the fecal PCR test. So we're using that, and we're also using a whole lot of other things on a group of sentinel animals. We're doing fecal egg counts, fecal larval counts, and we'll be killing some of them to get total worm counts. But fecal egg counts and fecal larval counts aren't particularly useful or accurate in deer, and that's one of the reasons why we're looking at the Kala. So this is just a quick graph of some of the stuff to date in one of the groups. And what you've got there is those dotted lines are the fecal egg counts, and the solid lines are the growth rates. So don't pay too much attention to the absolutes of the growth rates, it's the relativities. So the orange line there are our suppressively drenched group. So they're the group that's getting constantly drenched. You can see every time there's an arrow in there, they're being drenched. So they're being drenched every fortnight. So yes, their growth rates were going down as we're coming towards winter. You see in that other line, the blue line there, we started, so that's 2 weeks post-weaning, is that first weight, and they were growing reasonably well. And then the parasite challenge started coming up, and their growth rates dropped down, and in this case, 6 weeks post, they'd dropped down below, they'd gone into a negative growth rate, and we'd meet our trigger control, so we had to drench them. So then you see that next time they're picking up again. And I can tell you further to that graph now, they're already picking up another challenge. So after 4 weeks post that drench, we already had some groups that had picked up a fecal egg count, and it looks like 6 weeks post drench, we're probably going to hit that lack of live weight trigger again. And what we're really looking for from this Kala trial is to know whether that Kala response actually relates to a productivity response. And if that does relate to a productivity response, then we can move forward, and the first thing we'll be moving forward with will be offering breeding values officially. So in this last season just past, 6 or 7 breeders actually opted to use Kala, and we produced breeding values for it, but it was unofficially, it was outside of Deer Select, so not necessarily endorsed by the industry, but those breeders believe in the measure at this stage. And the other thing we can get is all the genomic stuff, hopefully, that we'll be able to develop or discover genomic measures of this immunity to parasites. And the big thing for me is that we'll be able to jump into this whole digital revolution, and I'll be able to evolve out of using this digital into using a swab in the mouth. Next thing we got here is the mini bolus. And so this is all about, we know the drenches aren't really working that well right now, or the old drenches weren't. And the old drench was essentially a sledgehammer approach. It was, okay, we've got these parasites, what do? We'll hit them as hard as we can. And we're still essentially doing that now with our new drenching regime, except we don't have an acceptable withholding period. And this mini bolus uses a slightly different approach in that it's more of a lighter tap on the head than a smack with a sledgehammer, but it's done over a series a day, and in this case it's done over between 4 and 5 days. So it's delivering a much lower dose, so the overall total dose over that 4 days will be lower than what the current recommended sledgehammer approach is anyway, but it's delivered over a lower day, and at the moment that will be a combination drench. So in terms of the development of that, this has been development essentially from the ground up, so it has been working with a group of farmers to get their feedback and input, because we know a bolus isn't a particularly palatable item for anyone, but the thing with the bolus is that it's an area that we as Ag Research and the industry have freedom to operate in. So we've got freedom to freedom from the constraints of patents, let's say. So the patents that the drench companies hold are all about wet chemistry. The bolus is a dry chemistry, so we've got freedom to operate and formulate it however we like with whatever we like in this space. So that's why it is a bolus. You can see there from the size of it, it's about 5 centimetres long now, and this will be pretty much close to the final product, and it's the same diameter as an 8-gram copper bullet, and a lot of that's from the farmer feedback so that we can produce a gun. And again, the gun is being designed with a panel of farmers, some of whom are in the room today, and engineers from AgResearch, and that's to provide a gun that will make delivery as easy as possible, and it will also deliver the 8-gram copper boluses as well. So that's still being developed and designed, but when you look around and think about it, most of your drench delivery options at the moment are either a sheep gun or a cattle gun. Nobody's gone to the trouble to make you a deer-specific delivery as well. In terms of the actual ongoing work right now, we are about to start next week the first efficacy trial at Invermay. So the few of these will be going down some throats at the end of next week. And also, AgResearch is in discussions with a commercial partner. There's nothing come to fruition out of that yet, but potentially there's a New Zealand-based commercial partner that may look to move this forward. We don't know exactly what that'll look like yet, but that's good news in terms of having someone to actually deliver it to the industry. The stuff that has also been happening in the background has been, the stuff that's going to happen next year is going to be testing on more farms, and particularly we would like to test it on farms that have a liver fluke challenge, because Dave Lethwick believes that this has an efficacy against liver fluke, and he believes that they'll probably be able to get a label claim against liver fluke, which none of the current registered deer drenches deliver. And we'd also like to test it on properties that have got purported drench resistance. So if anyone feels that they fit in those categories particularly and would like to be involved, come and see me afterwards. The gun work, as I said, is ongoing, and these have all got sort of go, no-go points in them, but if we hit the go point, then we will move on to looking at trials that would be used for registration purposes. And in some of this earlier trialling, we will be trying to be a little bit efficient in that, and that some of the trials we do will hopefully lead towards the registration. And down the bottom there you can see that's the boluses taken out of rumens of sheep, so that's how they degrade. So after 2 days, that one is about half degraded, and that's after 104 hours, which I think is about 4.5 days, and that's almost totally degraded. So it's a sustained degradation and release in that mini bolus. And the last thing is a drench resistance assay, and this is an assay that came from the cattle industry, and what we wanted was a quick and easy way to determine whether or not a farm had drench resistance if the drench didn't really seem to be working for them. So a lot of this work was done in the last financial year, and there was a few farms that purportedly had drench resistance, including Invermay, and all the Ostatagias were cultured, put through this assay, and they all sort of died at the same place in the assay. So that asks a couple of questions. Does the assay work, or are these deer parasites not actually that resistant, or at least as resistant as they see in the cattle parasites? So we needed to get our hands on some parasites that we knew were resistant, and this is the ongoing work at the moment, and it's about a crossover experiment, and essentially what we're doing here is we are putting some known cattle ivermectin resistant parasites into some deer and some cattle, and then we're putting our Invermay strain of purportedly resistant parasites into another group of deer and cattle. These are all indoors. There's a lot of fecal sampling going on, and it's going to be larvae cultured out of these that then go in to test that assay. Now, I can't tell you an awful lot more about this because it's actually been very slow to get the infection patent in the deer. It all happened nice and quick and easily for us in the cattle, but that delay in the infection, what it's done with us is it just raises more questions. So all this parasitology work that we're doing as farm systems scientists, we have the parasites come down and we say, oh, well, why does this happen, or why doesn't this happen? And they go, well, I don't know, I thought you knew. And so what we find out about parasitology is essentially there used to be a lot of basic parasitology done about the parasites, and then they went, oh, we found a sledgehammer. We don't need parasitology research anymore. So essentially for the last 20, maybe even 30 years, parasitology research has mostly been about finding sledgehammers. It hasn't been, as we would do in our industry, about understanding the animal. So there's a whole lot of different questions about deer and parasites and parasitology that need to be answered. And that leads on to some of our new work and the exciting new thing that we've got happening in this coming year is that we want to get to know about the fundamentals of parasites in deer. And so they're starting a postdoctorate, and that's going to be on the life cycle of lungworm and gastrointestinal parasites in deer. So that's about getting back to the basic fundamentals of the biology of the problem. So it's learning about the problem rather than learning about another sledgehammer that you might be able to use to kill that problem. Thanks.
We've probably got 1 minute for questions. We've probably... So I think we do have 1 minute for questions, because bearing in mind that we've had Jamie present on 3 and possibly 4 different parasitology topics. So if there's anything burning, yep, there's somebody at the back there.
Assuming that you continue to reach your milestones and the bolus continues in development, when you go for registration, will you look to specifically test for withholding periods in velvet?
I would think we would have to. I don't know whether that's been fully considered yet, but because the first goal is the venison production system, there's velvet coming off that venison production system, so I think that the withholding in the velvet will be important.
All right, thank you very much. Health and safety slide here. We've been talking about drenching for 15 minutes. This poor lady got on the wrong end of a drench gun. Any suggestions on what she should have worn? I'm hearing white t-shirt. Hang on, Jeff. Just to pick up from what Jamie was saying about efficacy trials on a mini bolus about to start next week, Deer Industry New Zealand's been hearing as well that all things being equal on efficacy, many farmers would prefer liquid oral. A liquid oral that would have a short withholding period and that would work well against parasites that are reportedly resistant. So what DINS has done is committed to investing in development of a liquid triple oral drench if there's a commercial partner. So we're in discussions with a commercial partner for whom that would be a good fit in its portfolio. There's nothing signed as yet, but the good news is that a very small pilot efficacy trial on a liquid oral combination will be starting next week. So that's great timing that it's in parallel to the work on the mini bolus, because it would allow the boards to evaluate whether one or both of those projects should go forward into development. Jeff, so I'd like you to give a very warm welcome to Jeff. Jeff is known to many of you. He is, to me, he epitomises the passion in Passion to Profit, because he's absolutely committed to first-class deer research, and he has a very loyal, he inspires a band of deer scientists, not just on the Invermay campus, but on the other ag-research campuses. So I know I give Jeff a hard time, and I found out yesterday that Shiny Bum from Wellington was the most polite of the terms he calls me. I'm desperate to find out the others, but I do value Jeff immensely. So over to you, Jeff.
We love you, Catherine. So I've got the Swede one first. So I'm giving 2 talks. They're quite different. They're very brief summaries of firstly a trial we've completed, and secondly some work that we're starting. So I'm going to start with the effects of overwintering of hinds on Swedes. And the background to this is that we had found some prior association between the feeding of Swedes over pregnancy with high rates of abortion on R2 hinds on some farms. And it was worrying to me that perhaps Swedes might be the cause of this. And particularly as, you know, Swedes are relied upon heavily in the south as a winter and feed system. Also, about the same time, you probably would have all heard about the problems on dairy farms in Southland, where we had toxicity problems with Swedes leading to actual deaths and poor performance in dairy cows. Now, there are some issues around that in terms of what caused that, but it sort of started this line of inquiry is two factors. One is Swedes can become toxic with glucosinolates under certain conditions, and maybe there's toxicity effects. So glucosinolates are hepatotoxins. They affect the liver and have very profound effects on animals. And also, Swedes are known at times to become protein deficient, and whether there is potentially an effect of protein insufficiency on the development of the fetus and leading to abortion. So we thought, well, it's very important that we at least look to see if there is a possibility that this might be happening in deer. So we set up a couple of trials. Now, I'll acknowledge right at the start, crops are notoriously variable year in, year out, and Swedes are a classic. They can be good one year and bad another year, and it's impossible to replicate those conditions in the field. But we wanted to take a stab and see if we could actually see if there was association with abortions. So we had a small trial on Invermay, which was very intensive. We had 80 hinds, 40 R2s and 40 matures. Half of each group was split across a Swede crop and half on pasture silage. And we intensively looked at fetal loss, live weight gains, liver damage through the use of enzymes like gamma-GT, and protein uptake by actually measuring blood urea nitrogen levels, and just see if there are physiological effects of animals going on to Swede. The other one was a larger scale trial with collaboration with the Landcorp farm, where we had over 900 R2 hinds, which we randomly split across Swede crop or pasture silage system. We were more interested in the grosser effects of fetal wastage, but we did have a sentinel group where we measured the other things as well. But, you know, as I said before, we can't control the seasonal conditions that influence the crop. So, you know, there's always a rider in this that we don't know what's going to happen in that crop. Some of the outcomes of that study was that if we, and this is a combination of the two trials together in some respects, but we didn't actually see a significant effect of Swede on abortion rate, particularly on the large farm. It was 5.4% in R2 hinds versus 4.4% for the controls. Now that sounds significant, but it's not statistically. And it's a modest abortion rate, not a high abortion rate. Some of the abortion rates we have seen have been up to 15 to 17% loss of fetuses, so quite dramatic. Not a common phenomenon, but as I said, it was the only thing we could see was association with Swede. The glucosinolate levels that we measured in the Swedes were quite high. However, the assay for glucosinolates is a very difficult assay. As soon as you damage the Swede, the levels go up. And you're supposed to use liquid nitrogen in the field to fix it straight away, and we couldn't do that. So I'm a little doubtful whether the levels were toxic, but certainly there is no indication at all of any liver damage coming through on the enzyme indicators of in the deer. So either the levels weren't toxic or deer are tolerant to the glucosinolates. The interesting one, though, is in most of the crop, crude protein levels were quite good, over 15%, and the deer seemed to do well on them. One of the paddocks we used on Invermay was only 8%, which is marginally deficient. And the interesting thing is those animals showed an immediate drop in indicators of protein intake, much faster than I would have thought of. And I'll show you that very shortly. Overall, the live weights gains on the crops were good, so the crops were useful in that respect, but we did experience on Invermay, with our perhaps lack of experience in using Swedes, that the phase-in period needs to be treated carefully. We had initial drop in live weight, so phasing them into swede crops is an important process we need to consider. Sorry, I've gone the wrong way. So this is actually a graph that shows the blood urea nitrogen, BUN. And you see that in those two, and towards the end there, where the swede groups, which have the solid symbols, entered a paddock with only 8% crude protein, within a day, their blood urea nitrogen had dropped dramatically. There's no buffering in deer by the look of it in terms of protein uptake. So it's a very immediate response. Now, fortunately, they weren't in that situation probably long enough to do any major damage because we didn't see any. But it does show that crops can be deficient in protein, and we need to be very careful about that. And I would suspect if they'd been on there longer, we would have seen metabolic problems in relation to the pregnancy. Conclusions. High live weight gains on swedes are fine if the protein content's good. And there's plenty of farmers who can attest to good outcomes from using swedes. So I'm not trying to spread any message that's negative. We didn't actually see any abortion effects, but in itself, because we weren't able to replicate really, really bad conditions, it doesn't say that swedes can't cause abortion. What I think it says is we need to be aware of risk factors. Protein content can vary enormously, and protein is an easy thing to measure in crops. So I would recommend that if you are relying heavily on swedes, do frequent protein checks on the swedes. And if they start falling below 12%, start supplementing with higher protein supplements. Don't assume you're going to get the same results between years on the crops, even in the same paddocks, or you rotate swede paddocks anyway, but don't assume you're going to get the same thing each year. Transitioning of hinds to pasture swedes is important. It needs to be over 2 or 3 weeks, needs to be done carefully. We learned that. The Landcorp farm had no problem at all. He did it well, and the animals kept growing quite well. It's hard to predict if swede crops will become unsafe, and the risk factors around glucosinolates are generally they elevate under stress. And so when you get conditions that could include drought, then you can start getting elevation in toxicity, and we're very careful. But it's virtually impossible for you guys to measure glucosinolates in the crop, so don't rely on that. You need to rely on understanding the risk factors. Glucosinolates concentrated in the leaf, especially during bolting. So bolting is showed in the picture on the right, is when the plant goes into reproductive phase and it throws up the long stalk. Yep. And that's when it becomes toxic. The problem with cattle in Southland is because the crops were so heavy, farmers kept the cattle on them longer than they would through the bolting stage, and that's where the problem occurred. This is a photo I took from Dairy NZ, and their standard unit of measurement is a gumboot. So that's what that is in there. The dairy industry has a much more refined measure. That's a can of beer. Yes. That's a long gumboot, but seen down. They're not very smart in the dairy industry. So so that's the sort of take-home messages there. Swede is a good crop, but you need to manage it very carefully and be aware of the risk factors around it. Thank you. Yeah.
Is there any way to measure what's causing the protein to drop in the swedes? You know
What's causing the protein to drop? I wish I knew. I don't know. It was very unexpected to see such a difference between two paddocks. They were slightly separate, the paddocks, slightly different systems, but I wouldn't have expected to see such a difference between them. But it is something you can measure very quickly. Yeah.
Just a percentage leaf difference, Jeff?
Didn't appear to be, but hard for us to say. I have to say we're not really experienced in Swedes. We don't use it very often, so perhaps we missed something there. But for all intents and purposes, we couldn't tell. Yeah.
Did you feed them silage on the Swedes?
We did feed a little bit of silage on the Swedes.
You talked about the Infamay,
Yeah.
not the Infamay, the other farm that the phasing was better, were they feeding silage?
Yes,
And
silage.
Never helped their phasing work.
Yeah, yeah. Although the amount of baleage feeding was quite small, we'll have to say, but yeah, baleages are buffering in the system for sure. Yeah.
All right, any further questions on sweets? Can you bail Jeff up at the morning tea? So he's going to move on now, thank you.
What if I don't go to morning tea? There's too many people talking at morning tea. Okay, changing topics completely, and research deer and the environment and managing waterways. I'll state right from the start that as I go through this talk, I did not collude with the Honourable Nick Smith. Some of the things are just purely coincidental that we came out the same thing. His talk yesterday was very, very good, very balanced, and take heed of it. And that would be my message as well at the end of this. Why bother? Well, I think you've had enough of it yesterday to understand why you need to bother. Environmental protection is part of the primary sector's social licence to operate. It's going to hit you. There's no getting away from it. 95% of New Zealand is urban bound, and they don't understand farming systems, and they are putting the pressure on us to change. What we want to do is demonstrate that the regional rules can be met by simple changes. I think a lot of people are worried about draconian changes coming upon us. I would argue that if we look very carefully at this and have an evidential-based process, that a lot of this won't actually hit us that hard. We need to address perception versus reality gap for deer when we start looking at actual impacts, because unfortunately we don't have a very good grounding of actual knowledge of what deer do to the system. And so what you get when policymakers set policy is they use worst case scenarios or they base it on the wrong evidence. So really what we want to do in the research side of things is help you in the industry support the policy leadership by DINS in order to make sure that policymakers set reasonable bounds for us to operate within. It's a pretty simple concept, but there's a lot of work to do. There's a number of things that have been underway now. I set the cat amongst the pigeons a few years ago when I invited the Regional Council to Invermay, and within 5 minutes they had told me we didn't comply and we would be prosecuted if we didn't comply within a certain time frame. We were pretty dirty. A research farm was pretty dirty. It was jaw-dropping for me. And we're prepared to admit it. We didn't get it right. Now, we set up the farm 40 years ago and it was a different environment then. No one thought about that sort of stuff. We're not going to castigate ourselves about it, but we're all in that boat. We all need to be very aware of our shortfalls in these circumstances. Our rules around Otago Regional Council Rule 6A for water quality, which is a bash around sediment, but it doesn't really matter, in my opinion, what the contaminant is. The principles are all much the same and apply across the country. So we've gone on a journey by setting up a focus farm where we're prepared to put it up, warts and all, what our problem was, and I have a web page coming up shortly. We're populating at the moment. There's some pretty hairy pictures in there. But, we've got to show it so you can see how we're going to fix it, or have fixed it. Now, the environmental focus farm was a bit of a failure, as it was very hard to get engagement at field days. And so we're now morphing in with the help of DINS to an advanced party, or advanced parties, focused around environmental management in the region. And I'll come back to that later, because you need to go on this journey, go on the journey together. And the advanced parties, look, I'm sold on advanced parties. That's the way to do it. For instance, this is some of our mitigation. After 2 years of simply putting a short fence to turn a nasty wallow draining into a stream into something that becomes a sediment trap and looks a lot nicer and is cleaner. It can be done, and it can be done very simply in many cases. So, as I said, this is evolving into advanced party. I'm not quite sure when it's going to be up and running, but hopefully it's early in the new financial year after July. And we will be part of that. We'll be advanced party member. We're prepared to be there. We've got to change too. But it has spurred a bit of action into doing some research on Invermay, and we're using some money outside of my program. We have a paired catchment study, where if you look at the photograph on the right, you'll see a series of small streams coming off one face. So we will then monitor those little streams. We've got monitoring sites in place. And then over time, we'll put various mitigations in some of those catchments and look at the effects. And, you know, it includes sediments, nitrates, phosphates, E. coli, and any other contaminants. And then the mitigation practices and how they affect those. But, you know, Invermay is hill country, and hill country is the heartland of New Zealand deer farming, but it's not representative of the entire deer industry. So, with that in mind, I put up the concept that for starting in next year, we have a new project for the deer industry, which we put in front of various stakeholder groups for feedback, and they almost unanimously came back and said, yes, do this, we need it. And that is to start monitoring waterways on hill and high country properties throughout New Zealand. To be honest, I put this up 10 years ago and I got negative feedback from the industry. We should have done it 10 years ago because we'd be in a better position now, but the industry's matured. It's realised that it needs this sort of situation, so better to start it now than not at all. It's 5-year monitoring of individual streams, starting next year with at least 5 properties. We may add more in future. And we're targeting central North Island hill country, eastern flank South Island high country, subalpine stuff, and central Otago southland high country properties in the next year. And I've already talked to a number of farmers and already arranged properties for some of this area, so quite pleased that we're, and you know, I have to say every one of them said, yep, go for it, you know, really keen. The focus will really be largely around critical source areas or point source areas, how to identify them, how to mitigate them, and finding practical solutions to mitigate it or farmers to identify the problems. In most cases, you'll be able to easily identify the problem. It's how you mitigate it. Farm participation is sought, and I will say for those I haven't approached yet, it'll be minimal impact on the farming operation. All we will need is people to monitor their livestock in and out. And if we have to get them to do water monitoring, we'll pay them as part of the project. So the idea of this is to actually have an evidential-based approach to providing the information that policymakers can set realistic things and not blanket uneconomic systems for mitigation, which we're facing at the moment. I'd have loved to say we had it now and it was in place, but it's not. So in summary, the deer industry needs to be not only proactive and active. You can't avoid this anymore. No burying your head in the sand, you've got to go with it. Better industry level data to inform policymakers and regulators is a key factor in this, but farmers are enabled to identify and address critical source areas rather than suffer from the uneconomic blanket mitigation rules that a lot of us are facing at the moment. Fencing off all riparian waterways on hill high country is not going to work, not for anyone. But finding practical and cost-effective means to effectively mitigate damage to waterways is the key to it. Okay, thank you.
Thank you very much indeed, Jeff.
Talk at morning tea?
Talk all you like at morning tea.
Yeah. Are you going to take questions now?
We don't have time for questions now,
Yeah,
so
I
we
knew
can hold
that.
fire until morning tea. I just thought we should wrap up by, you've heard about a few specific projects that have been underway, but just to give you a bit of an idea about what's in the Barnes programme and what's new, and the forthcoming deer research programme, I thought I'd take you through that. I wanted a picture of Collier because he's now the chair of both Barnes and deer research. I wanted a picture of him in his gumboots and shirt sleeves. The best I could come up with. This is him doing his chairman's thing. Bit of yoga, bit of levitation, doing a few strategic thinking tasks. So you haven't heard about any velvet research today. I just thought I'd show you what's in the programme underway. The first one there is RepairX. Dan and I will be happy to talk to you about RepairX in the break, but a quick summary there is that rather than us continue doing human clinical research ourselves, we're now looking for a commercialisation partner who will take RepairX and run with it and put it in the market. Isotopic signature test pilot, that's a pilot study to develop a test by which we can identify whether velvet in the market originates from New Zealand or not. So that will underpin the program the velvet audit program Reese already has running in Korea. Stem cell mediated healing is a new PhD which started about 6 weeks ago, and that's based at the University of Otago, and that's looking into the biology of the processes that go on post-velveting, so we can understand more about the fundamental biology and then learn whether there are any commercial applications of stem cell healing. In green, that's just a very small investment Barnes makes. Puts a bit of money to get velvet researchers together, both in New Zealand and then supporting an international velvet symposium. So that's to build on velvet research capability and to find out what's happening around the world. And what we've got planned is on the animal welfare front, there are a few proposals for the NVSB to look at to assess the stress and pain that the stags feel post-velveting, and to assess whether there's any need for long-acting analgesia. And healthy brain aging is a really interesting area that Barnes has got some seed funding for from the Research Trust, but via the Woburn and I forget the full name of this society. Warnham and Woburn, thank you very much. That's to look into the potential uses of velvet to support healthy brain aging. It's a massive growth area in research, human research around the world. We've had the money for a little while, but we're taking our time getting going because it's such a big area. There's so many different metabolic pathways you could look into that Barnes wants to take its time and be absolutely sure that it's picking the right project. So we've had a few proposals, but we've had a bit of expert advice that perhaps you need to look along slightly different lines. So the other thing we need to do in that space is try and leverage our money, do our best to see if there are other funding avenues that can support this type of research, because it is very expensive. So I'm happy to talk to anyone in the break about any velvet stuff in more detail. If this man got $1 every time we showed his picture, he'd be putting in for early retirement next year. So you'll be glad to hear that I've negotiated a royalty of nil. So the research program for next year for deer research, so we're going away from velvet back to deer research again. Most of those projects you'll have heard a bit about today. The ones to look at are the ones in bold, because they're the new projects. Now you heard from Jamie about the fundamental parasite biology PhD. You heard from Jeff about the long-term monitoring of deer and its effects on the environment. So the one other new one in bold there is a look at what are the incidents and sources of deep muscle hemorrhaging. So that's where the processors have noted defects that they in leg primals that they're unsure what the cause of. They want us to have a look at what the extent of the problem is, to try and put a number on, quantify it, and then see if there are any potential causes and solutions to that problem. So the processing companies through the Venison Processors Technical Committee are very engaged on this, and they're getting together already, to, sharing their knowledge and working out ways that they can contribute data and other information to that. So that's a very quick rundown of what we think the deer research programme will look like next year. And with that, I think that's the end. Morning to everybody.